make it this concept that Fs equal to Pv. Just wait, I think someone is hanging on. Sorry. So how it should be? Say the surface work or anything we do the linear work. That means we applying force and it has some displacement. Then it is actually the work. And then if you apply certain energy or force that will expand or compress some volume system or fluid system, it also pressure and volume variabilities will make the work done. Because actually we do so, because we can transfer this solid mechanical work into fluid work, and this fluid face the volume variation with force or pressure, actually it is actually work. So how we can make them interrelation? Can you understand that how we can drive from one to another? Say we have this, so how we can find it? Say we have this, how we can find this? Do you know that how it can be found? Yeah, then the surface work is done by pushing or pulling any system. Sorry. Then the work in the fluid system actually done by thermal expansion or energy actually expansion. So this is actually how it expand or compressed in the variation of volume with pressure or force. It do the work done. Then actually it is transferable from the solid system to fluid system. So how we can interrelate them? Anyone can explain it, that how we can get from force displacement system to pressure volume system? I think I discussed a bit something before. Anyone can? Please try to do so, that how force is actually nothing but how related the force with pressure. Please relate this one first. How force is related to pressure. Pressure is nothing but what? Force per unit cross section area. It means that whenever you write force in terms of pressure, it should be P into A, yeah? P is pressure, A is cross section area. Then S is actually the length or displacement. So pressure, area and distance. Area and distance is actually volume. So if you apply certain force, then it will displace certain length, say del L, and area cross section A. So A into del L is actually del V. Cross section area and change in length, the direction of application of force, the length change del L, totally should be volume change dV. So think that force we can transfer into F equal to PA. P is pressure, A is cross section area. That means pressure is force per unit cross section area. That means force equal to pressure multiply cross section area. Then length itself is, you can write in very infinitesimal area length, or you can write the total length. So L or dll, whatever it is. If it is del L, then change in volume will be del V. Oh, just wait. I think someone knocking. So can you get it that how we can get the Fs coordinate to PB coordinate? Fs coordinate to Pv coordinate. Understand or not? Because work done, actually we know a different way. Electrical work is what? Then we can write it in electrical work also, or energy. What is electrical energy? Say We is electrical, Wm is mechanical, say Wf is fluid system work. So different work. Actually, the law of thermodynamics it shows that it can transfer from one form to another form. So such a way how we can transfer the electrical work also. Electrical work is what? Electrical work is what? So electrical power is what? Electrical power is electrical potential and the current flow. And you know current flow is nothing but charge flow per unit time. So electrical power, whenever you make certain time derivatives with integration of electrical power at certain time frame, it will give you electrical energy. That means electrical power P into del T, actually nothing but it is del We, that means electrical energy change due to time del T. It is actually V and Q. V is the potential, Q is charge. I don't know whether you can write it or not, because I cannot write here. That is the problem. So this is the electrical potential and charge multiplication. That means how much charge you can lift against the electric field or electric potential. It is actually the electrical work. Here also, how the massive thing you are applying force, it can push certain distance. This is the mechanical work. But it also can do in potential energy part. And that work, how we can transfer into fluid system, that is the PV. That means Fs equal to PV. So can you understand that it is transferable? Yeah. Then the electrical work, it should be VQ. V is actually electric potential, Q is electric charge. Oh, I don't know, the student coming late. Uh, so understand this point, or we can proceed later on. I will discuss again. Then you know that the surface work, fluid system work, and the push-pull system work by applying force to an massive body, and the work done by thermal expansion or volume. So think that any involvement of energy change, actually it is under the first law of thermodynamics, that energy can be transferred from one form to another form. So the mechanical work, the fluid system work, electrical work, all are equivalent. So these are the key understanding of energy transformation process. So far we not yet discuss about the mass flow or volume flow. If so, then find out W equal to Fs and Pb unit. You know the unit, what we need to write. Force unit is what? Force unit is what? Force is Newton, yeah? And you know force equal to F equal to ma. M is mass is kg. A is acceleration, it is meter per second square. So it is kg meter per second square. Then again there is a length. So kg meter square second square. So that means m kg, if you represent by m, so what should be the meter square second square is v square. So think that it is transferring from fs to actually mv square, mass and velocity square. So this is the dynamic phase of the energy. Understand or not? F is itself is ma. M is mass, a is acceleration, meter per second square, kg meter second square. It is actually nothing but that force, kg meter per second square force. Then the displacement due to the application of force itself is another meter length. So kg meter square second square. So it should be, if you represent it in the physical entity, it should be mass into velocity square. So think that how W work is equal to F phase transfer into mass velocity square. This is dynamic phase because it is kinetic energy. Mass velocity square is kinetic energy. So previously we already discussed that the F is equal to PB. So both are equal. It should be kg meter square second square, or it should be actually, you know that it is joule. It written in the unit of energy is joule. So 1 joule equal to 1 kg meter square per second square. So that is the unit of work. And it work should be followed the same unit. It is MKS unit. So think that is it kinetic function or not? Because you already found it. It is mv square. M itself mass equivalent, v square is velocity square. So mass and velocity square itself are considered kinetic form of energy. So think that this is the dynamic phase of energy, that we do the work. Any massive body that push forward, it is actually achieving certain velocity due to continuous application of force or acceleration. That's why it gets the velocity. I think I understand. So this is definitely kinetic energy. Then how temperature change in fluid energy? So that means application of temperature or heat, how we can change the fluid energy. So think that whenever we applying heat, the fluid actually become more volatile, more volume process. But if it is confined area, it just make pressure on the system to extend it. So if it can change the volume, then due to the pressure, that volume change, that is all actually the work done. So how the work done? It is done by temperature, application of temperature. That you are heating the system, it trying to expand. So due to the application of heat, it expanding. That is actually in a form of PV dynamics. This one, yeah, pressure volume dynamics. But in the piston system, if you push this, it actually due to application of force, it is compressing. So some distance it move. This is the surface energy you are applying in a mechanical system, and ultimately it is transferring in the volume dynamics. That is the uh, fluid system change. So this is actually the temperature, because you can apply force to change the volume. You can apply also external energy as heat. Force mechanical energy, heat also as a form of mechanical energy. So it can transfer. So this is what, say this is kinetic energy is mv square by 2. Yeah, actually we write in the form at average energy as a mv square by 2 kinetic energy. So if any system of mass 100 kg and its velocity is say 20 meter per second square, so it should be definitely think that it is actually 20 kilojoule. So kinetic energy itself is joule, but it is in the kilo scale because it is more than 1000. That's why it written in kilojoule, 20 kilojoule. So this is the simple way we consider the kinetic energy. Then how about the energy density, kinetic energy density? Because before we discussed about it, the kinetic energy, potential energy, energy density. So this one is what? This is the potential energy. Think that it is Gz. So it is nothing but it is actually potential energy density. Think that Gz or Ga is whatever you write. It is actually not there is no mass involvement here. So it is per unit mass, it energy level. So it is, say the g acceleration due to gravity, if it is 9.78, and if it is a certain height, say 30 meter, any system, so definitely it should be 293 joule per kg. That means it is 0.293 kilojoules per kg. So this is the kinetic energy in the total form, not energy density. It is total energy. It is potential energy in form of energy density. So the kinetic energy as a total energy and potential energy as a energy density we can represent such a way. And why energy density I will tell you later, because mass actually is not in the static form, it is dynamic form in the fluid system. That is called mass flow. Then water flow as hydropower system, if we consider, so this one is what? Say we have a water height or area, a dam that built in a dam, it can rise the water level 160 meter height. 160 meter water height. So think that this is the reference level, this is the ground potential or our earth surface. But the water written here against the gravity or potential, it is actually 160 meter. That means age is 160 meter. But you cannot measure the mass of the water because it is huge. So how we can consider it? It is actually the flow rate. How? Say what is the purpose? Purpose is we are building a dam or barrage to produce electricity from water. So as long as the height of the water is more, definitely the rotation pressure at the, so think that here they make open at the bottom. That means wherever the pressure is highest, what happened? Due to the high level of water, the pressure should be high. Because you know, before last week we discussed that whenever a fluid system height is higher, the mass should be, sorry, the pressure must be higher, and the pressure must be at the bottom is higher. So if so, then this pressure actually turn the turbine to rotate, and this turbine actually is coupled to the, this rotor is coupled to the generator. Generator is coupled actually the magnetic field. Then ultimately it produce electricity. So think that how many interface here, potential energy to rotor interface, then rotor to generator interface, then generator to the electrical system interface. That means the line transmission of the power, electric power. So here is one conversion, here is another conversion, here is another conversion. So three-step conversion can change the water into electricity. That means each step there is certain loss or efficiency variation as output and input. Here mechanical to mechanical conversion. That means the potential energy of water transfer into the mechanical energy of the turbine, the rotational torque. And then the rotational torque of the turbine is coupled with the generator. It is also rotational, but mechanical to electrical transformation here. Then electrical to the ultimate power supply. So both stage there are a lot of electrical equipment and mechanical system, frictional loss. So it consider almost 60% efficiency. So now I should consider mechanical or potential energy, because here due to the level of height of water it possesses certain potential energy. But whenever you make hole over here, then this potential energy transferring into kinetic energy, and this kinetic energy water flow rate actually controlling the turbine rotation or rotation, and this rotation actually ensure here electricity generation. So this is actually potential energy possessed by the water by the height of the water dam. Then the mechanical or potential energy density. Yeah, you know the energy density you need to measure, because energy per unit mass is actually energy density. That means sorry, What is this? Whenever you get certain dot at the top of this is work. At the top, workflow. Workflow means actually energy flow. So workflow means mechanical energy flow, and mechanical energy flow is nothing but mass flow and mechanical energy density. The small e is actually energy density. So you should measure the energy density first, and then you can measure the energy flow by considering mass flow. But mass flow, how to measure? Yeah, it should be have to measure different way. I will show you, because you cannot understand that how about the water level, how the flow, because mass flow determined by the area cross section here, not the whole water. This water will determine your pressure, that how the water will flow through this hole. That is called volume flow. Any volume per unit time, how much water is flowing, it is called volume flow, not mass actually in terms of volume flow. So then you should consider mass flow in transformation of volume flow, and then from volume flow you can get the mechanical energy. I'll show you later. Now wind flow energy as windmill. You know, similar as water flow, there must have wind energy flow. Wind energy flow. How? Uh, you know that this is the wind turbine. It facing against the wind direction. So if so, what say wind velocity is 10 meter per second, is huge, yeah. It will cross the blade of the turbine and it must rotate. So such rotation actually coupled to the, this is mechanical rotation torque, coupled to the generator at the back, and that is similar as here. This rotational torque coupled with the generator, it will produce electricity here. Here also, this rotational torque by the wind speed or wind velocity, it will rotate the rotor inside or generator, inside the magnetic field, and ultimately it will produce electricity. So here how many parameter we need? We need the diameter of the blade, because here total diameter is shown 60 meter, is huge, very big. So the flow of air, the the diameter of the cross section of a blade, how we can get? So the mechanical energy density is actually, you know that before I told you, that is mv square by 2, but it is nothing but v square by 2, because it is energy density, that means energy per unit mass, v square by 2. So you already know v is the velocity of air, so you can easily find the mechanical energy density. That what else you required? You required mass flow, because mass flow into mechanical energy is the energy flow. So the mass flow is nothing but, what is the definition of density? Density definition is what? Density rho is m by v, mass per unit volume is density. So if you consider that, actually mass is nothing but density and volume. So volume actually, you can write that the volume is actually, but here no more mass, it is mass flow, but it should be what? Volume is say cross section area and length. Cross section area and length is volume, yeah. But whenever you write the mass flow, that means here is a time derivative, mass per unit time flow. So here should be density cross section area, then length divided by time, that is the velocity. That means density, velocity and cross section area. That means density, velocity and cross section for circular, because the whole system is rotating, so it looks like a circle. So the circle diameter is here 60 meter. So understand it, it is 60 meters. So it should be pi 60 square by 4. So whatever it is the measurement of mass flow. That means air density almost 1 kg per meter cube. Then velocity here is 10 meter per second. Then the area cross section is pi 60 square by 4. So you can easily find the mass flow. Then you multiply mass flow with the mechanical energy. Mechanical energy is nothing but velocity square by 2. That means it is again this. So it means the velocity q by 2 totally in terms of velocity. So think that how significant the air velocity for generating electricity from wind turbine. That's why mostly the wind turbine installed in very high altitude on the mountain or somewhere in the tropic region in close to the seaside where the air blow or air flow rate is very high, because here only the parameter is variable, other you have to make fixed. Say diameter of the blade is fixed. Then it's actually the density are fixed. Then for particular system the diameter or cross section area is also fixed. What is the variable parameter? Only the velocity of air. Velocity of air is variable. So depending on this velocity, you can develop different energy. That is, up to this level is mechanical energy. Then this mechanical energy, this rotor connected to the generator, ultimately it will transfer into electrical energy. Similar as hydropower. So understand the scenario that how we should design or thinking it to make the energy efficient, non-renewable, renewable, hydropower and windmill. This is the simple mathematics or simple presentation or design phenomena that how you can make the energy efficient for renewable technology like hydropower and windmill. Now, the water and air flow. Water and air flow. What is the difference between water and air flow? Because water density is very much higher than air. Water, the per unit density is actually 1000 kg per meter cube. The water density is 1000 kg per meter cube, whereas air density is 1 kg per meter cube. That means about 1000 times higher than the air. That's why the water flow is not like the open, like the air flow. It is actually very controlled inside the on the bottom of the reservoir, and it determine the cross section of the pipe, determine your water flow rate, volume flow rate, because they are also the same thing. Rho is density, pi d square, by 4 is actually the energy density, similar as shown before. So that why the water density is too high, so it volume flow is no need required like the air flow. It should be much less. That means the cross section area of the pipe that move for connect to the rotor for movement, it is required less uh, diameter of pipe, because the density is higher. Water density is 1000 times higher than air density. It is actually on a much more higher, yeah, because you know that the water, 1 liter water is 1000, sorry, 1000 milliliter is 1 liter. So how much it actually, the weight is almost 1 kg, because its density is unity. And if you consider the in meter cube, it is actually 10 to the power 3 kg per meter cube, because 1 liter actually 1000 cubic centimeter. 1 liter is 1000 cubic centimeter. That is almost 1 kg. But whenever you consider the meter cube, then it is actually more than 100,000 times more. Then how density is involved with them? Yeah, density is how involved, because we already discussed. Because air density is actually 1 kg per meter cube, whereas water density is 1000 kg per meter cube. So it is huge compared to air. That's why the water flow rate required minimum to ensure that same amount of mechanical energy as we can find to 1000 times greater, either the velocity of water or the diameter of the windmill, that will determine the same energy flow. Because water density is much more higher than air density. So in case of water and air flow, what are the variables? So variable is actually, in case of water flow, the variable is actually the height of the water dam, that how much it potential energy pushes. Then the diameter of the water flow rate, water pipe, water volume flow rate. Another is the volume flow are related to mass flow. You know that this is a mass equal to density multiply volume. So if you make it all derivative with time, so mass is mass flow, density no more change with time, then volume is volume flow. So volume flow we can write it such way in terms of mass flow and density ratio. So now another thing is actually it is very much important for electrical engineering also, that how we can make the insulation of the house system to make it cooling, say air conditioning cooling system. So in that case we need to minimize the energy flow from inside to outside. Then we have to make the air shield system. So how we do so? There is a conductivity of materials that we can make wall. If it conductivity level, it cross section area level, and it temperature difference with the length of air. That means the depth or breadth. How to say, the wall. If it is larger, then it can minimize the control. It can maximize the control of flow rate. Q means conductive flow of heat or energy from inside the room to outside the room is determined by the cross section of the wall. How it is protective to control the flow of air inside the air. So which one can design? Which one can design variable? So what are actually the can make variables of the design? That is the length or cross section of the wall, and definitely the temperature. You know that we have to maintain comfortable temperature, say 20 degrees Celsius, and outside say 35 degrees Celsius. So difference of temperature you should consider that to flow rate, to control the flow rate of the what say air or hot air. So in that perspective we can consider, this is very primary level, I will discuss it later. So if you consider the thickness and energy loss, that means energy that got conductive loss through the wall or the obstruction system. So here you can see that as long as you are increasing the thickness, definitely the loss of energy is getting lower. It means that this is wise to design the thickness of wall much more higher, that can avoid the heating energy or cooling energy to transfer. Which energy come towards home? Cool move forward to heating area or heat move forward to cool area? Energy flow is actually hot. The cool air can flow outside or the hot air can try to come inside. Definitely it is the hot air, because thermodynamic knowledge is that the hot energy always very much dynamic, and it try to move comparatively less heated area. You know that whenever you heat a certain thing inside a oven, or sorry, inside a say the gas stove, it definitely it moves the heat faster through cool the hot area to cool area. This difference of the temperature between hot area and cool area, it accelerates the faster energy flow through the system. That is actually Newton's second law, that the rate of change of heat or heat flow from certain system actually determined by temperature difference. That means if this is higher, then this is definitely higher. If this is higher, this is definitely lower. These are two constant almost. So I think now we should proceed the discussion. Yeah, I first go. So we move it fast. Then I will discuss later it. Discussion in the. I think it's better to go to the chat form first. Before that, we just do the attendance first. These are very simple problem solving, but it has a very good impact on understanding of the energy flow. Mm. Oh, sorry. I think here it has. Shifa, Shufa, whatever. Mm. So please do first the attendance first, then I will move for discussion. And later on, we come back again for elaboration of the. So I think better those who are holding the iPhone, please write down your. Mm, because every day need to enter the student attendance.
Sir, hello, sir.
Yeah, please.
Need
Yeah, please.
I need you to scroll down the QR code a bit because it's not coming out from on the screen.
Oh, okay, okay.
Okay, okay,
I don't know why it is moving down here.
okay. Thank you, sir.
Uh, how many actually the iPhone or okay? I don't know why it is not saving here. If it's on save, then it can easily do. Mm.